Okay, now we're doing right angle trigonometry. So a right angle triangle has a 90-degree angle here. Call this angle gamma, 90 degrees. These two other angles are alpha and beta. Greek letters because that's traditional. Opposite alpha is side A, opposite beta is side B, opposite gamma is side C. Now, all right, some identities. The angles of the triangle add up to 180 degrees, as they do in general. So therefore, alpha plus beta is 90 degrees. So alpha is 90 degrees minus beta, and beta is 90 degrees minus alpha. So these are complementary angles. Given one, we can find the other. A over C is sine alpha, and it also equals cosine beta. Therefore, by doing some transposing, A equals C sine alpha and C sine beta. A over B equals tan alpha, so A equals B tan alpha. And it's also B over tan beta from here. C, from here, we can transpose the C here and get that B equals C cosine alpha, and also equals C sine beta. From here, we get the transposing in A, we get the B equals A over tan alpha. No, sorry, from here, we do some transposing. You get B equals A over tan alpha, and transposing here, B equals A tan beta. And then from here and some transposing, C equals A over sine alpha, and also A over cosine beta. C equals B over cosine alpha, and B over sine beta. So, okay, but solving for the various letters, we can find A, B, and C in terms of the other letter and one of the angles. Of course, this is a right angle triangle, so A squared plus B squared equals C squared. So, therefore, C equals square root of A squared plus B squared. A equals square root of C squared minus B squared. B equals square root of C squared minus A squared. Then, since A over B equals tan alpha, alpha is the arctangent of A over B. B over A is tan beta, so beta is the arctangent of B over A. Have we covered arctangents yet? Not yet. In some way, so this is in some sense an unfair question. That's a bit, but all right, we'll get to it in a couple sections. All right. So we have some examples. Here we have a right angle triangle. We're given alpha is 35 degrees. Side B is 12.1 degrees. So what's A? Side A, it's angle beta. What's side C? All right. Well, all right. Beta is 90 degrees minus alpha. And we're given alpha. It's 35. So beta is 90 degrees minus 35 is 55 degrees. Okay. Now we know B. We want to find A. We know alpha. A over B equals tan alpha. So therefore, transposing the B, A equals B tan alpha. That'll be 12.1 tangent 35 degrees. And a little running with a calculator, you get 8.74. You should need a hand calculator or some such device for doing trigonometry on the fly. Used to be they had trigonometry tables in the back of a textbook, but calculators have made that all obsolete. At one point, I was actually giving a class, and I would look up the tangent and the sine in the back of the book, then calculate on my calculator. Then I stopped for a moment in front of the whole class and said, "Why bother?" Because it had a sine, cosine, and tangent button on the calculator. So technology moves along, makes all systems obsolete. Now there's C. Well, B over C, we know B, we know alpha. B over C is cosine alpha. So if you transpose the C and transpose the cosine alpha, C equals B divided by cosine alpha. That's 12.1 over cosine 35, and therefore C is 14.8. Here we're given a right angle triangle. We're given angle alpha. We're given side A. Oh, this is known and this is unknown. So what's B? And what's C? And what's beta? Well, as before, beta is the complement of alpha. 90 minus 20 makes 70 degrees. Okay. A over B is tan alpha. So transposing the B and the tan alpha. B equals A divided by tan alpha. 13.7 over tan 20. So B is about 37.6. A over C is sine alpha, transpose the c and the sine. C equals A over sine alpha, 13.7 over sine 20, or 40.1. Here we're given A is known, alpha is known at 42 degrees. C is given to us at 17.5. What's A, what's B, what's beta? Well, all right, beta is the complement of alpha. 90 degrees minus 42 degrees makes 48 degrees for angle beta. A over C is sine alpha. Transposing the C, get A equals C sine alpha. That's 17.5 sine 42, or A is 11.7 about. B over C is cosine alpha. Transpose the C, get B equals C cosine alpha. That's 17.5 cosine 42. That's 13.0 approximately. Here we're given two sides of a right triangle. A is 3, B is 4. What's side C? What's angle alpha? What's angle beta? Okay. For side C, use the Pythagorean theorem. Root of A squared plus B squared, that's root 3 squared plus 4 squared, which is root 25, which is 5. C is 5. Now, given given A and B, tangent alpha is 3 over 4. So A is arctan 3/4, or 36.87 degrees. Tan beta is 4 over 3. So beta is arctan 4 over 3, or 51.13 degrees. Here we have side A is 1. Side C is 3. What's B? What's alpha? What's beta? All right. Now, side B, by Pythagorean relation, B equals root of C squared minus A squared. That's root of 3 squared minus 1 squared. It's root 8, or simplifies to 2 root 2. Now, for alpha, opposite over hypotenuse is 1/3, or sine. So sine alpha is 1/3. And okay, this is again jumping forward into the book, means that alpha is the arc sine of 1/3, or 19.47 degrees. Similarly, for beta, 1 over 3 is the cosine. So beta is arc cosine of 1/3, 70.53 degrees. I could get it from here just by subtracting 90 minus 19.47 degrees. Just a second, let's see what we have. Okay, here. Now here we're getting into some trickier trig. We have two buildings, one of height h, another 2,001 feet tall. From the base of the first building, you have to crane your neck upwards 35 degrees to see the top of the second building. So this is called an angle of elevation of 35 degrees. From the top of that first building, you have to lift your head upwards by 15 degrees, an angle of elevation of 15 degrees to the second building. So given height h here, so therefore this height h here, this unknown height k here, the question is, what's the height of the first building and what's the distance between the buildings? All right, here's what we have. 2001 over d is tangent 35 degrees, opposite over adjacent. So okay, 2001 over d is tan 35. So after some transposing, d is 2001 feet over tan 35 degrees, or approximately 2,857.7 feet. So we have that already. Now, this distance k is 2,001 feet minus h. And if you look at this triangle here, k over d is tangent 15 degrees here. And therefore, tangent of 15 degrees is 2,001 minus h over d, which you already got, is 2857.7. So if you transpose the 2857 and do some more fiddling around, you get that h is 2,001 feet minus 2857.7 times tan 15 degrees. And that works out to 1,235.3 feet. So the buildings are 2,857.7 feet apart. The Schroeder building is 1,235.3 feet high.